Okay, well, good morning, everyone. I'm Joe Gianpietro, architect and passive house consultant. And so it's now 9:10. I'll go ahead and start this presentation on the mini ZEPH backyard cottage, give you a little background on how it came to be. And there will be a few steps along the way where we have opportunities for discussion, questions, and of course, in the chat room, you can always bring up your thoughts along the way. So to start, the session is being recorded. And in general, I think people have already started by muting themselves when they aren't speaking. That's great. Chat room is great for asking questions. I'll try and pay attention to that along the way. So we will jump right in. So the story here is that about 10 years ago, I approached the carpentry instructor, Frank Mestemacher, at the Wood Technology Center and asked them if they were interested in building a small passive house modular unit. And Frank said, sure, we'll have the students do that. So over the course of 2010, 2011, they built the Mini B passive house. And that was on display at the Finney Ridge Neighborhood Center for about a year. And then it was moved to Bothell, where it's now a guest house at Clearwater Commons. Then 3 years ago, we were in conversation again, Frank and then the new instructor, Katie Chaplin, about whether they wanted to build another modular passive house. And they said, sure, let's do it again. And that began the path down this road, which is the mini ZEPH. And you see in this image the original concept idea of that building, looking at it from the alley on the back of the lot that I co-own with my daughter, who was happy to have this house had a backyard cottage passive house. So you see at the bottom of the screen the mini B floor plan with a kitchen, bath, living area on the main level. And on the right, you see the mini ZEPH lower level, which was built on site. Bedroom, bathroom utility, and a garage storage area. And of course, the stair which connects the upper and lower levels. The upper level, which we're in right now, has a living, dining area, a bathroom, and a bedroom. It's about 432 square feet if you count it from the exterior of the wall. And on the left, you see the Mini B passive house loft area, which includes a mechanical loft on the right and a bedroom loft on the left. And the interior pictures of both, the Mini B from 10 years ago, the Mini ZEPH from today. Just to give you an idea of sort of the perspective, both of these were built to the Passive House standard as managed by THEIS, Passive House Institute US. And while neither have been formally certified, they have met all of the criteria in design. And I'm working on getting the Mini ZEPH certified over the next few months. Next, just a few images of the original design. You'll see on the cross section, on the roof of the cross section, that there are solar panels. That represents a 4,400 kilowatt solar array, which would make this a net zero building. And we don't have them installed yet, but we're planning to do that this fall. The plan in the lower picture shows the basic layout and the windows and so on, where we have maximized windows on the upper portion on the top of the picture toward the south. And those windows will have shading devices, a tree in the bedroom, which is already there, and roll down exterior shades on the living dining area. So east is the deck area that gets morning sun. West is the bedroom, which faces the alley and gets evening sun. That's sort of the general picture of how it lays out. in the submittal to the city for permit, you'll see we've added the stair on the exterior that was built on site. So just again, the big picture is the module of the upper level was built at the Wood Technology Center. The lower level and the stair, the deck on the left, were built on site by Bucktide Construction. And a couple of differences between the original Mini B and the Mini ZEPH today. They both have similar windows in terms of being triple pane. One on the left is the Mini B, and the windows came from the organization out in Colorado. The name escapes me right now. The windows on the right are from Eurotech in California. So the main difference is that while the Mini B had a conventional 2x4 construction with a lot of insulation on the outside, the Mini ZEPH is a SIPS panel wall structure where the insulation is contained within a 2x8 wall assembly. So it's a more efficient wall assembly, can be smaller, and because it's a larger unit, we were able to get by with a lower level of insulation. So from R50 in the walls on the Mini B to an R35 in the walls on the Mini ZEPH. On the left, you see here the Mini B under construction with 9 inches of foam insulation going on the outside. On the right, you see the Mini ZEPH under construction with the SIPS panels that are clad on the outside at this level with vapor shield exterior weather barrier. Then briefly, looking at an energy analysis of the way SIPS panels function, you see a graphic image of heat transfer. So if the interior is warm and the exterior is cold, in the extreme case, you see how the studs, in this case, because they are not every 16 inches, they're really every 8 feet in a SIPS panel wall, they don't interrupt the insulation value. It becomes a very smooth transition in the corners, both in the floor plan and the wall to roof section. In the floor, we have a different situation because we have a framed floor assembly where all of our wiring and plumbing goes. So we had to do a special arrangement on the exterior to add that orange mineral wool blanket along the perimeter beam to create the same similar continuous insulation path. One of the typical features for a passive house building that are particularly valuable in today's very smoky gray world is having a heat recovery ventilator, because what it's doing is it's bringing in fresh air that is filtered, takes the smoke for the most part out of the air. In addition to that, besides being a full-time ventilation system, it's also doing heat recovery, so keeping the cold out in the wintertime and the heat out in the summertime. We also have a sand and CO2 heat pump, which is a high performance way of getting hot water for your domestic hot water use. It is located in the main house on the site, and we have a very well insulated pipe from the main house to this building for a circulation loop. So we're both the main house and this house are using the same tank. It became a very cost-effective solution. A few slides showing the actual construction on site at the Wood Technology Center, which is located in the Central District. We have on the left the building plan, the floor plan of 12 by 36 being assembled in the shop. On the right, it's been moved outside into the yard, and you'll see it elevated to a height of about 3 feet that allows moving truck to come under it and move it over to the side eventually. I have a question here about the square footage of the building, so I'll quickly divert to that. The upstairs unit, which is the module, is 430 square feet, and that building costs about $125,000 to build, not including the student labor. So going back to the images here, we have the SIPS panels being assembled on the building in these pictures. And let's see, you'll notice on the window end here that there is a steel frame to resist lateral forces in that open end. Bit of an expense, but it worked out well. On the right, at the lower picture, you'll see how we had the exterior siding installed. And what's unusual here is the siding is a flame-treated cypress siding, known in Japan as Sushugiban siding, or Sushugiban treatment. And it's installed in a vertical manner over a horizontal framing system, rain screen. A little time consuming for installation, but it came out really great in the end. Here are a few of the people that were key in helping students understand what to do and how to do it. We have in the upper right, Katie, who is the instructor, done an amazing job with students, teaching them about high performance building as well as all the practical techniques of good carpentry. In the background here, we have Todd Bell, a premier SIPS, who was great in helping assemble the building besides providing the panels themselves. Not for free, they were at cost, but did a great job instructing the students in how to assemble a SIPS panel building. On the left here, we have Kevin Nolan of Vapor Shield demonstrating the Vapor Shield product that we're using on the building, on the exterior as a weather-resistant barrier. Lower left, we have Dan Whitmore of the FIAS Technical Committee showing the students how to install a passive house window so that it is able to be carefully installed and well sealed. In the middle, we have Tadashi Shiga of Evergreen Certified, who conducted several blower door tests along the way to show the students how they're doing. And on the right, we have Pat Downey of Proseco demonstrating how you seal joints with their liquid applied flashing system. The window end of the building as it's built, one of the students is proudly in front of it. And in the other pictures, we see some of the students working on the interior casework, which they built from Baltic birch plywood.
Baltic birch.
And here is the entire group, at least of the last year of construction before we moved the building. We have Katie Chaplin, the instructor, on the right, her assistant instructor on the far left, kneeling down, and some 25 students who are working on this particular section of the program. Given the fact that the building was under construction for 2 years, it was actually, I think, 6 different student sessions, many of whom were there for 3, some of whom were there for 1, but we probably had about 80 students involved overall learning about high performance buildings. So here it is up on its cribbing. There was a open house for the school to show off what the students had done in March, and it was ready to be moved. So I'll just take a little break here and have a discussion if anybody has any questions at this point before we move on to the moving the module. So I'm opening the floor for comment or discussion.
Well, you built that on the ground and lifted it up.
I'm sorry, I didn't quite hear that.
Why do you? I don't know if it was on those things to start with. It looked like it was on those stacks of wood.
So the previous image, it's set up on cribbing to hold the building 3 feet above the pavement. So when we get to move it, the trailer can slide right underneath.
That needs to be 3 feet up.
There's a question of R values of the walls. They were, off the top of my head, I think they were R40 in the wall assembly. No, R35. The roof was R49. This is not a house that was at Shoreline Community Solar Fest. No, there was another zero energy house then a few years ago. And on this screen, you'll see obviously my contact information. If you have any other questions you want to ask after the event, I have my email address is probably the best way to reach me. Or if you're interested in the wood technology program at Seattle Colleges Wood Technology Center in the Central District, you can contact Katie Chaplin at Seattle Colleges or go online. They have a great program in boat building, cabinetry, and carpentry. I do hear a little conversation going on. If there's any questions to address to the group, please speak up. Okay, let's move on to the next series of slides here.
I just sent a question via the chat.
Okay, let me take a look. What are some of the disadvantages of SIPs for installations where they don't work? Well, I was involved with the Pax Futura project, which is a 36-unit passive house in Columbia City that was using SIPs as well. And that sort of inspired me to do it on this building. It depends on the weather conditions of your construction. If the panels get wet during construction, it's a problem because they start to grow given the fact that they're clad on the exterior with OSB. So in that case, over the course of the length of the building, they had a few inches of growth and they had to adjust for that unexpectedly. So that's one disadvantage. You have to deal with wiring and plumbing in the walls in a special manner. We had to lay out all the vertical penetrations through the SIPS panels in advance and make sure that they were built into the wall system so that we could run wires from below in the wood framing up into the proper locations in the wall. Having a SIPS panel roof meant that we decided not to put any wiring or equipment in the ceiling itself because that would make it more difficult to get to. So there are some adjustments you need to make. The advantages are you get a very well insulated wall system that's easy to make airtight. It's also simpler in some ways to quickly put together a building frame that might take less than a week as opposed to a month or more. So I think it's a great way to go for very specific circumstances, and maybe, for example, doing backyard cottages where you move the panels in all assembled, put them in place. It's probably quicker than doing stick framing. So I will advance the presentation. The next piece of this is about the site preparation, which was a little more involved than I really, well, let's take a break here. The sponsors for this event, the Green Home Tour, Mighty House Construction, Green Home Solutions, Dunlubber, Green Tools, King County, Pathway Design, and 475 High Performance Building Supply, which is based in New York, but has offices here also in Seattle. So a lot of specialized equipment can be purchased through 475. So anyway, this is the site for the mini ZEPH before any work took place on the back of this single family lot. Existing garage, about 30 feet long, is going to be replaced by a similar building, a similar footprint, but 40 feet long. So this is what it looks like from the main house patio. And this is the corners of the building disassembled and laying in the play area of the house for a bit. And little Elio sitting in the original garage wondering what the heck is going on here. So you'll see him a year later enjoying the new garage. Anyway, so what we did with these walls is we took them apart in 4-foot sections and eventually reused them on the new building. What was more involved than we expected was getting the sanitary and storm connection from the house to the street. And just be advised that this was a major cost that we did not anticipate for two reasons. We originally planned to connect to the sewer system in the back of the house and run everything through the house. But the city does not allow you to run stormwater from the roof through a house because of the uncertain quantity. So we ended up putting a new service out essentially to the street, connecting to the existing home service, and dealing with some roof drainage issues on the original house at the same time. So a significant cost, probably added maybe $25,000 to the cost of the site construction. The second thing that took place, and you don't necessarily see it in this picture, is the fence on the left, which is the south side, was not on the property line. When we did the survey, we found out it was a foot off the property line, so the original garage was encroaching into the setback. So we had to relocate the garage slab about 1.5 feet to the north. So it added another cost of tearing out some of the concrete and building entirely new slab and footings around that piece. So you'll see that slab here going in. The alleys in the background. This is the slab with 2 inches of insulation wrapping it in a cover board what do you call it? Cementitious panels used in bathrooms. So it gives a good solid protective layer to the insulation. In the right hand, you see the slab ready to receive the new module and start construction. This is back in about January of this year. That little bump out on the left is the exterior stair that'll connect the upper level and the low level, and you can see the main house in the background. If you have any questions about the on-site construction, this might be a good time to bring them up, or we'll just move along into the next phase. The site work, by the way, was done by Bucktide Construction. Alex Saunders and his crew did a great job getting the trades together for all of the earthwork, sewer system, slab preparation, and then later the installation of the lower level. So continuing forward here, moving the module. Just to remind you, this session is being recorded, and feel free to ask questions along the way. So again, this is the Columbia site, Columbia City site ready to receive the house. This is the process of getting ready for the move. The trailer is coming in from South Lane Street into the yard, sliding under the building where it was correctly elevated to receive the trailer. And here it is going down Martin Luther King, up Dawson, and then into the alley as it's getting relocated to the site. Coming in, we had the good fortune of a wide alley location. Originally, the thought was we would bring it in with a crane, but we have overhead wires, as you see the sticks on the left holding the wires up. That did not allow that unless we had all the wires taken down beforehand. So we used the opportunity to bring it in on an angle, and here it is coming in. And the truck leaves while the building is still sitting sort of askew on the slab, and then pulls out. The next day, we had a very great crew of people who were specialists in moving and elevating modules, and so they came in with their equipment, slid the building so it was rectangular to the site, and started raising it up on cribbing. Here you see their system. They have an amazing hydraulic system of pumps that they raise in sections and get it up to ended up being about 10 feet off the ground when they were done, as you see in the lower right. And then we added, started adding the walls. The very first wall here on the east end of the building. Any interested questions or thoughts about the move or the challenges we had? I can tell you it cost about $15,000 for the move, the lift, and the set. Most of that was actually the lifting and setting. It was only about $2,000 for the trailer to move it. So it's one of the cost considerations depending on where you are. So continuing on, on-site construction. So once again, here are our sponsors for this green home tour, and moving right along. The on-site construction involved a 2x4 structural wall, which you see here, supporting the module. And the primary structure for this is this bedroom on the east end of the building that supports the east end of the module. A couple of posts along the way. Then on the alley side, the shear walls around the garage. These are the Simpson shear walls around the garage. So it was a very simple method of supporting the building that relied on a few points of connection. And the significance of that is the original design was going to be leaving the original garage in place and just putting structure on the interior of a 14-foot wide garage. It would have been great if we could have lifted the building on top of the existing garage, but circumstances of the wires do not allow us to do that. So it still is a very simple support mechanism. And once we got that all in place, we felt confident that the building was going to stay put. And what you see here is the basic framing of the support system in place. The openings on the garage end here are for windows into the garage that will allow it to be a workspace, office, yoga studio, whatever the family living here in the main house chooses to use it for, because that'll be for the main house and not for the residents of the mini ZEPH. In this picture, you see a pipe coming out over the doorway. That is the intake for the heat recovery ventilator, which then turns the corner and goes inside. So in the lower picture, the intake is in the left side, the exhaust is on the right side, the exhaust goes out to the south side of the building, the intake is on the north side of the building. So they're completely separate, not crossing over the air paths. This little picture on the top shows how those pipes were then connected up into the heat recovery ventilator upstairs in the main building, in the upstairs unit. In the final installation, we are using the heat recovery ventilator upstairs to serve both the upstairs and the additional bedroom, bathroom, and utility in the lower level. And here you see some of the ground level services being installed. Plumbing pipe, ventilation pipes for the bathroom, bedroom, and utility room. And in the bathroom wall, between the laundry and the bathroom, we have all of the plumbing that connects from upstairs into the ground. Another picture showing the ventilation pipes that were routed from the upstairs into the lower level. A little more exciting pictures of the plumbing wall. This picture represents where the upper module stops and where we've extended a deck to the left over the lower level bedroom. So this space is the lower level bedroom. And then we proceeded to have the entire lower level insulated, both in the 2x4 structural wall and the 2x4 exterior wall with blown in bats. So we ended up with about an R, close to an R35 in the lower level as well. Here in the left, you see the original garage wall panels in 4-foot sections that were stored on site. We repaired them. We put treated plates on the bottom. We built in a rain screen behind the old sheathing and shingles, and then reinstalled them on the outside of the structural wall. You'll see here in the lower right the combination of reused garage walls on the left in the main building, and then in the stair we used ZEPH panels, we used hardy panels to match up with the coursing of the shingles. This detail gives a little bit of information about how that assembly works. So the main unit above with the main beam, I've got a pointer here. The main beam was built in the Wood Technology Center yard. There's a ZEPH panel above it. Everything below this line and to the outside of the beam was built on site. So here's the structural wall below the beam. Here is the plywood sheathing from the construction on site that is acting as the air barrier. All the joints were sealed, so it makes an airtight building. Then on the outside of that, we have the second 2x4 framed wall, which was the original garage wall, in which we installed a weather-resistant barrier, an air gap, and a plywood support for the weather-resistant barrier. It's also vented out this way, and this allowed us to install 4.5 inches of mineral wool on the outside of that beam to provide the continuous insulation across this section of the building. Continuing on, this is more images of the insulated interior structure. There's the exterior stair, which is actually not part of the heated enclosure. While it is insulated and airtight, it is outside the main building and will not be heated. And it connects the upper and lower levels and probably steals some of the heat leaking out of the building, somewhat little heat that there is. Then going up the stair, you're entering the top landing here that goes into the module. What we did with the windows in the stair is we had 4 windows in key locations to provide light to the stair, views out without compromising the privacy of the main house, yard and patio. So it worked out really well because many of these windows, like the middle one has a tree behind it, the right one has a tree that provides screening between this building and the main house. Then this space, which I think my daughter's family is particularly thrilled about, is inside the garage, looking out at the entry to the mini ZEPH on the right and their yard on the left. So a very nice view into the yard from what they will probably be using as a home office while the COVID experience continues. That'll probably start next week, where they'll be working there. This is the interior of the garage before sheetrock. And this little guy, Elio, on the right, who I showed in an earlier slide, is now thrilled that he can push the button on the garage door and open and close it. So my question here at this point is whether you have any thoughts or questions about the whole construction process that took place on site. Feel free to unmute if you'd like, or ask questions in the chat box. So let's go on. I've added this information here in case you have a reason to contact either myself or Alex Saunders of Bucktide Construction. So we call this the Welcome Home, a treetop retreat to show off the finished backyard cottage. And I'll also let you know that on your screen, there's a variety of things you see besides this presentation. If you were to look at the primary screen and go down to the lower right under media, you'll see a PDF you can open at your leisure. When you leave this particular site, you can see the following slides that are coming up here for the finished product. So this is the entry from the alley. You can see the garage and the windows on the right, the main entry door to the stairway that takes you to the lower level and then up to the upper level, and the main house, sunroom, and deck on the left. And this is the view from the alley. Along this fence is where the parking spot will be for people who come to stay here. I love the siding. It's a great complement to the original shingles of the original garage. I see a question here, total cost of the project. Well, let me just take a brief moment to digress on that. The original plan was for the module to cost around $125,000, not including the labor of the students, and for the site work to cost about $200,000. In the final analysis, I think we ended up spending about $140,000 for the module, and the site development work of the slab and the sewer connection increased that work to about $250,000. So we're close to, I think we're about $350 to $375 overall. And that includes the entire site work, lower level, upper level of the building for about 1,000 square feet total. The prefab unit is 432 square feet. There was a question there from someone. Okay, so continuing on the tour, we have the lower level entry. You can see the stairway in a winder fashion going around the corner there. This is a view slightly into the lower level where there's a laundry, bathroom, and bedroom. So making it a 2-bedroom, 2-bath house. The winder stair going up around, you'll see through the window a mini view of the patio or the steps up to the patio of the main house. Then coming in the door into the living dining area, this is the view that you get from the upper level, which has a great exposure to the south and to the east. Lots of green. Today you don't see much beyond the local area, but it has a great territorial view and exposure. This is the kitchen, again, built by students using Baltic birch plywood with exposed edges. And it's pretty basic. There's 24-inch modules in this kitchen. So you have a 24-inch refrigerator, 24-inch range, 24-inch base units, and a 24-inch dishwasher on the right. And really that gives you all the things you would need in a small, probably a bit more than what you might really need. You can see there's a little bit unfinished patch around this ductwork here, which leads to a supply duct over at the right end of the kitchen. And I'll have to show you that more in a bit. I see a quick question about the students. Students were of the Seattle Central College Wood Technology Center Carpentry Program. Those are the ones who built the module, the upper module. So continuing forward here, you can see here there's two very large windows on the south side that will shortly have exterior shades. They were late arriving from Colorado, but they will be on remote control to roll down when you want to shield the unit from summer heat, but open in the wintertime to gain passive solar. So at the moment, we get a little bit warm in here because we don't have the shades up yet. You can see these windows are the German tilt-turn variety. They're currently tilted on the left to allow fresh air in without any rain or security concerns. So it's kind of an interesting deal. You can also set the window to open in a complete swing fashion as well. So this is going back a little bit into the hallway, then looking out from near the bathroom door on the left into the bedroom. The bedroom in the west end of the unit. It has a great window to the south here and a tree, fortunately remaining in place on the site to screen it from excessive solar gain, but also adding a beautiful filter to the house next door. Then proceeding back out, the bathroom door on the right. It's got a shower on this level, a good size vanity, and behind the door is a linen closet. One thing I didn't point out to you was the bedroom closet is there on that sliding door. So proceeding back out to the living area, we can go out to the deck. And here is looking to the south and looking to the north, where we see this strategically placed magnolia tree screening the main house, patio, and sunroom. So we've managed to keep it in place for the benefit of both parties. Then we're going to take a little tour back down the stairway. This is the upper landing. Down the stair, and here is the lower level bedroom. A great sort of TV watching location if you don't need it as a bedroom, but we have a pull-out couch as well. This is the lower level bathroom where you have the tub, whereas upstairs has the shower. Laundry room, which in this case has two high performance appliances, a heat pump dryer, and a low energy washer. And a couple of the nice things about the heat pump dryer is there takes less heat to operate them. There's no exhaust air out because it simply extracts water and puts it down the drain. So it's avoiding another penetration through the envelope. It's avoiding extracting heated air from the building, and it basically keeps the room a fairly comfortable temperature. That's our laundry area. This is a view from the southeast corner of the property and from the neighbor's lot. A little more work to be done yet on the painting of the metal trim and the roof overhang above. But yeah, you can see in this picture how the windows in the living area are tilted right now for ventilation. This was the original concept of the building. We had the idea of it being oriented toward the west and the alley. And for a variety of reasons, we ended up flipping the building so this deck was on the east end. I think it's a much better solution for the sort of privacy of the deck area and letting the bedroom be on the alley end. So that's pretty much the end of the presentation. And I'd be glad to take any questions again at this point. I see one that's just come up here, which is what kind of siding is on the top floor? It is a cypress vertical siding that's been treated with flame treatment and then wire brushed. And it's obtained through a Portland company called Nakamoto Forestry. And I think it's originally sourced from a Japanese method, and I think it even came from a Japanese forest. Ended up being a pretty reasonable cost for something that would be a very long-term siding not needing to be painted. Been used for centuries in Japan for their various wood structures like I guess temples and so on that they want to treat very carefully. So it's a beautiful, let me go back here for a second just to show it to you again. It's got a beautiful wood grain, and okay, number one, it's cypress, which is weather resistant and decay resistant. It's been flame treated to make it more decay resistant, and then has a sealer on top of that. So I'm looking at hopefully many, many years of no kinds of painting or treatment on the siding. Yes, it's a Sugiban wood siding treatment. So if anybody wants to ask questions, you're welcome to do so. That's pretty much the presentation. And again, if you want to see that slideshow again on your own time, you can go to the lower right corner of your Green Home Tour website and find a media box in which you'll find a PDF of that particular finished product presentation.
Actually, Joe, can I just ask, is the stairwell tower, or is that going to be part of the enclosed building enclosure, or is it going to be outside the conditioned space?
So while it is insulated and airtight, it is outside the conditioned space. So it serves as a buffer area. You know, protected from the elements, somewhat tempered because it's not completely open, but it will be interior space that is not heated. So it's not part of the passive house envelope, nor is the garage. The garage, while well insulated and airtight, it is not part of the passive house envelope.
Thank you.
Sure.
Joe, on the assembly of the exterior reused wall in the garage and the you know, the interior structural wall, applying the insulation between the two wall structures, was that done before or after installation of the exterior wall? And secondly, did you consider, I mean, it looks like you're using, what kind of a foam, blow-in foam product are you using there? And did you consider any other like lower carbon or alternative natural materials for the blown-in insulation?
So the lower level is all blown-in fiberglass. And
okay.
The alternative would have been to use a paper-based solution.
Yeah.
But we decided to stick with what was the most common currently being installed and less likely to settle. So the way that was done is it was all one step. The insulators came on the inside. They made holes on the inside. I think there were a 3-inch hole to blow the outside wall cavity. Then while they were doing that and moving around the building, the contractor then sealed up all those holes with Proseco sealant and putting the little patches back in.
Mm-hmm.
And then they came in and they wrapped the interior with their fabric and blew the interior wall.
The mesh,
It's pretty
yeah.
much a one day process. And they also blew the ceiling under the deck and the ceiling over the garage to get the maximum R value in those locations. So the final product is probably an R30 wall in the lower level. And I think I said it was an R39 in the floor assembly over the garage. So all of that adds up to a passive house level of construction. Even though we're not pursuing passive house on the lower level, it's still just as airtight and just as insulated as the upper level.
Thanks. That's really interesting. Hey, Joe, one of the I put in the comment about it being zero carbon. I suppose technically it's probably zero carbon ready at this point, and when you put the solar panels on, it will be zero carbon, which means that the the overall energy efficiency was maximized from the very beginning. You used a passive house standard to achieve the ultra efficient building envelope, and all of the equipment is extremely efficient. So then you've got your energy loads as low as possible. You add a little bit of solar on it and you get to a zero energy, but also zero carbon, because you started off by maximizing the efficiency and building an all electric building that has no fossil fuel combustion inside. So just wanted to clarify what I meant there, but I know you've done a lot of leadership in that area, not only with teaching young folks how to build to this standard, but also advocating at the state and local level through Housing Development Consortium and other channels.
Yeah, I'll add that one of my passions right now is helping affordable housing go down this road.
Yeah.
And the Housing Development Consortium has a group of professionals. We call ourselves the Exemplary Buildings Task Force, that has been working with City Light, with the state of Washington, with individual developers to promote what we call a 2030 building, a building that is ready to be as efficient as what the building code will require in 2030, and with the addition of either solar panels or renewably sourced energy can fit the 2030 challenge. And so we now have 4 buildings, 4 affordable housing projects that are heading down this road, 1 that's under construction and 3 that are in the process of finalizing design, bidding, and getting ready to start construction. So it's a pretty big movement going forward here, and we're continuing to spend time and energy advising what the best procedures are.
Yeah, thanks for getting the Exemplary Buildings program started, Joe. I've been participating quite a bit lately, and for anybody else who's listening, I definitely encourage you to check that out. It's at housingconsortium.org, and then just click through to their Exemplary Buildings program, because it's those buildings are, I mean, they've actually created a lot of technical data materials, as well as had a bunch of workshops and trainings for affordable housing providers and designers. It's a great program that's going to provide a lot of technical advancement for affordable zero energy homes.
And 2 of the areas that I think are more critical, ventilation systems and hot water. We have done a couple of charrettes on those, and we'll be publishing those in the next month or so. And basically, the building code is heading toward requiring balanced ventilation, and heat recovery becomes much more cost effective with that, and provides the opportunity for better interior air environment, more comfortable living space, and at the same time energy saving. So it's one of those no-brainers, in my opinion, that will become standard over the next few years. And so we're trying to guide people in the way of learning how to do it effectively for multifamily buildings. So thanks for your comments, Chris. Appreciate it. Okay, a couple of questions I see here. One is, how much did the project cost? So there are 2 major, well, maybe 3 major aspects to this. One is the cost of the construction of the module at the Wood Technology Center, the cost of the move and the site work, and the cost of the finished construction. So the original projection is very close to what we ended up paying for the cost of construction. It was $125,000 for the upper module, and that did not account for the labor of the students involved. So if you were to build this without the student labor, probably another 50 grand. The site development and site preparation was another probably 75,000. And the rest of the lower portion was probably another 150,000. So building out the garage, the lower level, and all. So we're probably between $350 and $400 a square foot for the whole altogether. Now, another question I see online here is, did we consider using hemp insulation? I've been trying to focus, I have to say, on standard cost-effective solutions. And so I've tried to stick with what the trades are capable of doing today and can do it cost-effectively to produce as cost-efficient, high-performance, low-energy or zero-energy building that I could. So I've tried to stay in a more conventional mode. Things where I've really stepped out of that would be getting the best windows that are going to be more expensive. I've stepped out of that to use mineral wool, where it really made sense to use mineral wool, like on rooftop and deck top, to minimize moisture problems and around the perimeter of the beam. So other than that, we've really tried to stick with what's off the shelf, readily available. People are familiar with how to use the materials we have.
Could you explain a little further the black window, the exterior window trim?
Sure. So the wall system, we ended up placing the window flush to the exterior of the SIPS panel. We then have about 3 inches of the exterior siding assembly. And so we wanted to fill that frame around the window with basically a 1x3 cedar element. But we decided rather than paint and retreat that over time, we wrapped that cedar on 3 sides with metal. So what the students did is they were delivered the metal frame and the cedar, and they were able to put the cedar inside the metal and bend the corners and such, so it was as necessary to make it a waterproof wrap. So the sill is the bottom with turned up corners. Same thing with the head flashing with turned up corners, and then the siding frame comes down approximately 1 by 3.5 or 3/4 by 3.5 with a wrap around 3 sides.
So and at the corners, is there an overlap at the corner? The metal overlaps, or is it mitered, or how is that treated at the corners?
At the corner of the window.
Yeah, the corner there. I mean, like the top and the top
So
corner.
the sill goes outside to the framing and turns up. The side pieces come down and have a slight gap at the bottom of them. And the head flashing goes over the top of the side pieces and extends out about 1/4 inch and turns up. So all of those pieces, like the top piece, wraps back underneath to the SIPS wall and is covered by the weather barrier. There's a continuous path for drainage out at the head, and the sill covers the siding below.
Okay. Thank you. Yeah.
There's another question about, did Seattle do all the inspections? So one of the cool things about doing a module is they're inspected by the State Department of Labor and Industries. And they actually have a very straightforward, simple process that's really been ironed out by the modular industry. So you submit your plans to the state, they provide comments, you address the comments, and they give you a permit. And that permit is then, when the project is built and inspected by the state, the permit is then approved for installation that the city does not have to inspect the upper portion at all. They left that to the state. The upper portion is a completed unit. So what the city of Seattle did is they inspected the lower level and connections to the street. I hope that answers your question. So the city's inspections had to do with exterior sewer connection, general building inspection, electrical and plumbing. And all those are getting wrapped up here in the following week.
So you mentioned, I thought 1,000 square feet. I'm not
Yes.
sure, I thought ADUs were 800 square feet max, or did I miss something?
Yes, you did not miss anything. The truth is that city has changed their rules as of August last year, which have allowed you to exclude the garage as part of the ADU area. And they've actually upped the size, I think, to 1,000 square feet, although that wouldn't affect this structure. Because this structure, once you remove the garage, you then have your complying. And that's it for the moment. I think we'll take a brief break and we'll be back soon. Feel free to ask comments on the chat room along the way, and I'll be back and answer them in a few minutes.